So we are looking at problem 6 and probably only problem 7 in this video because they're both pretty long and I don't want to make any of the videos too long, but we're going to look at 6 and 7 at the very least on our final review. And problem 6 asks us to solve a system of linear equations by graphing. So we need to graph these two lines on the provided graph grid and then figure out where they intersect. That's what it means for them to have a solution to a system of linear equations. They touch at some point. So I am actually going to rewrite my lines over here because the grid is so large, it might be difficult to see. So we're just going to rewrite our lines right here so I can refer to them while I'm working on actually doing the graphing. So the top of our graph goes up to 12, the bottom is at -4, and from left to right, it's -3 to +13. So the up and down portion of our graph is the y, and the left and right portion is our x. And we need to go ahead and graph these two lines. And thankfully, graphing lines is actually not very difficult. And in fact, in big ideas, it's actually a lot easier to do than you might think. So we're going to start by graphing our top line. Y is equal to 3 divided by 4x minus 4. And the way that we begin is we begin by graphing at our y-intercept. And our y-intercept is at the point -4. That corresponds to the point of 0, -4. When x equals 0, the y value is -4. And the point where that is, x is 0 right here, y is -4 right here at the bottom. So that's our first point. And finding our second point is actually surprisingly easy because we just need to use our slope as rise over run. So our slope on this one, 3/4. So we need to apply rise over run. So we need to rise 1, 2, 3 units, and then run 1, 2, 3, 4, meaning our next point is going to be right here at -1, 4. And when you're graphing this on big ideas, you only need 2 points and then it will generate the line for you. So if you find your y-intercept and then you can count up 1, 2, 3, and over 4 units, you will have your line. And I'm going to go ahead and try and draw this in as best as I can. It's probably going to be a little bit prettier on big ideas. And by a little bit prettier, I mean it will definitely be prettier. We'll know for sure where exactly they intersect. We might end up having to guess a little bit on my version of it. If we go ahead and we look at -1/2 x plus 11, we now need to graph that one. And for this one, once again, we need to start at our y-intercept, which is at the point 0, 11. That's why they call it the slope-intercept form. For one thing, we're given our y-intercept for free, which is all the way up here. Our next point, we need to do our rise over run. This is -1/2. So I'm going to rise -1 and run 2 units. That puts my next point right here. From here, big ideas will again generate your line, and I'm going to try my best to draw this in accurately. Otherwise, it'll be hard to figure out where exactly they intersect. Let's try to be accurate. I think that will be, oh, whoops, you were looking at the top of my head, sorry. There we go. So we look at this and our two graphs clearly intersect at a point, and that point is right here. And if we look over, the x value of that point is over here at 12, and the y value is up here at 5. So our point of intersection is 12, 5. So you have to fill in 12 and 5 into big ideas. Something similar on the final as well. So you'll get points for both graphing the lines correctly and then figuring out where the two lines intersect. If it doesn't look like they intersect, you might want, or they don't intersect on the graph, you might want to redo your lines. All right, well, we managed to do number 6, which honestly isn't super bad. As long as you remember our tricks with starting with the y-intercept and then applying the slope as rise over run, you should be in pretty good shape. But let's go ahead and take a look at number 7. So number 7 asks us to solve this equation using any method. And there's a few different options available to us here. And I'm going to go ahead and go over 2 of them. I do not recommend that you use completing the square. The two methods that I would recommend using are the factoring method and the quadratic formula. Although the quadratic formula will definitely work, I wouldn't characterize it as being the best method. Factoring is the best method on this problem. When you get to the actual test, you won't be asked to justify what the best method is. You'll just be told, just solve. So let's go ahead and do this by factoring. When we factor something like this, x squared minus 3x minus 40 is equal to 0, we first need to think about what our a times c is. And the a times c refers to this in standard form of ax squared plus bx plus c. Our a value is our coefficient on x squared. Since there is no coefficient out front here, our a is assumed to be 1. Our c value is whatever this number here at the end is, which is minus 40. So we have negative 1 times negative 40, excuse me, which is negative 40, of course. And then our b value is negative 3. So we need to think about numbers which multiply to negative 40 and add to negative 3. Those numbers are negative 8 and 5. 8 times 5 is 40. A negative times a positive is negative. So negative 8 times 5 is negative 40. And negative 8 plus 5 is going to end up giving us negative 3. So we need to rewrite our original equation as x squared plus, I'm going to do 5x minus 8x minus 40 is equal to 0. And from here, we then need to factor out the greatest common factor. So the greatest common factor of x squared and 5x is x, which would give us x times x plus 5. And the greatest common factor of negative 8x and negative 40 is negative 8. So that gives us a minus 8 out here, and then gives us x plus 5. Since negative 40 divided by negative 8 is 5, which should come as no surprise considering we concluded that negative 8 times 5 was negative 40 30 seconds ago. So from here, we need to rewrite this as our final answer. We're able to factor out the x plus 5. That's our first set of parentheses. And our second set is the leftovers of x and minus 8. Wouldn't you notice that the numbers we picked up here ended up being plus 5 and minus 8 inside our solution? Anyway, from here, we're almost done. We just actually need to solve this. And as long as either one of these sets of parentheses ends up equaling 0, the entire thing will end up being 0 because they multiply. So that means we can set x plus 5 equal to 0 and x minus 8 equal to 0. To solve for x in the first one, we subtract 5 and we get x equals negative 5. Oops, that was not a very good, let me rewrite that so it doesn't look like x equals negative 15. X equals, I'm struggling to write x equals negative 5. All right. And on our next one, we have to add 8 to both sides, which gives us x equals 8. So our two solutions are negative 5 and 8. Now, the best way to solve this is factoring. And the reason is because it is easily factorable. Easy to do. Which is not like that good of a rationalization, but it's good enough for these purposes. Now, the other way we can solve this is by using our quadratic formula. And if you remember, our quadratic formula is x is equal to negative b. Whoops, let me get this on the screen. Plus or minus the square root of b squared minus 4ac all over 2a. And we previously identified that in x squared minus 3x minus 40 is equal to 0. A equals 1, b equals negative 3, and c is equal to negative 40. So we can go ahead and plug all these values in. That gives us x is equal to negative 3, because our b is also negative, so we're going to end with double negative there. Plus or minus the square root of negative 3 squared minus 4 times 1, that's our a, times c, that's our negative 40, all over 2 times a, which is once again 1. And from here, we then need to evaluate it. So negative 3 makes positive 3. We still have plus or minus. Negative 3 squared is 9. Negative 4 times 1 is negative 4. Negative 4 times negative 40 is 160. And finally, 2 times 1 is 2. From here, we then get that we have 3 plus or minus the square root of 169, as that's what 9 plus 6, 160 is. The square root of 169 is 13. So what we actually have is 3 plus or minus 13 divided by 2. From here, we are then able to solve this as two separate equations. One where we have 3 plus 13 over 2, and the other where we have 3 minus 13 over 2. 3 plus 13 is 16. 16 divided by 2 is 8. 3 minus 13 is negative 10. Negative 10 divided by 2 is negative 5. These are the same solutions we got earlier. It just took us a lot longer. The thing that's nice about the quadratic formula is it always works. So if you don't see how to factor something and you're asked to solve for a quadratic like we were given in this problem, just go for the quadratic formula. I like to call it the blunt force trauma method because it always works. So it just takes a long time and requires a ton of calculations, but you'll eventually get there. I am not going to show you how to complete the square on this problem because our b value is not even. If our b value was even, it wouldn't be that difficult, but because it's a -3, it would be annoying. You would still eventually get solutions of 8 and -5 though. So we're going to go over some more problems in another video.